Hello, welcome to part 4 of RevSim's virtual coffee break series featuring democratizing HPC. This is Bob Farrell with RevSim.org. I'm here with Wolfgang from the Uber Cloud and Alan from the Ohio Supercomputer Center. Just real quickly, I want to introduce you to the RevSim.org initiative if you're not familiar. It's a nonprofit global industry initiative created to make engineering simulation technologies more capable and efficient for CA experts and to make the technology more accessible and reliable for non-experts. It's what's being termed throughout the industry democratized simulation. And the results are numerous. Among what we're seeing are faster product development cycles, faster return on investment, and increased innovation. When you're finished viewing this webinar, I invite you to visit the site, register to kind of browse through a lot of the material on site, and of course sign up to receive our quarterly newsletter to kind of keep abreast of the latest technology news and everything related to revolutionandsimulation.org. So with that, I'm going to turn things over to Alan and let him take it from here.
Okay, thanks, Bob. I'm going to talk about a case study that's in the plastics industry, and to emphasize at the Ohio Supercomputer Center, we have a brand name for our industrial initiative called Awesome. That all that really is just a way to make it so that companies don't think they're working with a university that just wants to do a research project, because we provide a variety of services. And several years ago, we got engaged with a relatively small company called Greenlight Optics that has on staff experts in optical engineering. One of their product lines is some series of lenses for medical surgical lights. So if you've ever been in a hospital or seen a surgery suite, lighting is very, very important, and over the years they've been changing those lights to LED lights because of their longevity, stability, lack of heat, things like that. And those lights, it's not sufficient just to put an LED there, but you need to have lenses on them, A, to seal them, and B, also to be able to focus and collimate the light to highlight different areas of the patient, perhaps. So they make these lenses with an injection molding machine, similar to what's shown in the picture on the screen here. And for whatever reason, business was booming for them. They had a huge, huge backlog of orders for these lenses, for these injection molded light fixtures. And one of the important things when you are doing injection molding of a lens is you need to simulate not just the shape of the light, but also the optical qualities of the light. So that's what you're seeing a little bit here on the right. You can't have it be cloudy, you can't have the plastic be not quite the right curvature, or else the lens is not going to do exactly what you want. So Greenlight had this huge backlog of these particular parts, and they said, well, gee, we really want to fill these custom orders. We think that we can make the machine run faster cycles, but we don't have the time to actually take the machine offline, play with the settings, and see if that's actually going to result, because then we'll be even further behind in our backlog, production backlog, because we only have one of these machines. So we were able to provide them access to some injection molding software called Moldex 3D that allowed them to simulate the molding process and the various parameters of the machine and find offline what they thought would be some optimizations of those various settings of the machine to let them run faster. And as a result of that, they were able to actually reduce their manufacturing cycle by 64%. It was pretty amazing. They were really happy with that. Minimal downtime to actually make those changes to the machine and still maintain the quality of the lenses they had coming out of it. And for a startup company, like Greenlight that really established them not only as a strong competitor in the industry, but has allowed them to grow into other fields. For example, they're now looking at pico projectors, which is what you see here on the screen here. And those are jobs and things that might have had to be outsourced or gone to another company that they were able to have as a result of access to the modeling and simulation resources, which was not just the supercomputer, but also was the software and some of the expertise that we provided with them. So if you want to hear more about this or any of our other case studies, please feel free to visit the OSC website. We have one sheet of paper or 2 pages, front and back, case studies on this Greenlight Optics case, as well as other ones in other sectors. And with that, I'm going to go ahead and turn it over to Wolfgang.
Yeah, thank you very much, Alan, for this very interesting Greenlight Optics case study. And here are some final call to actions from the RevSim organization for our engineering community, which the stakeholders are the simulation consumers, engineers, etc., and industry organizations, academia, universities, research, etc. Simulation providers, mostly for the independent software vendors, the ISVs, service providers, etc. And certainly not to forget the media, which takes these messages out to the community, and also the industry analysts. And so with that, I want to mention that you can visit the Revolution in Simulation website, you can register, you can benefit from all the very different information which we all here, the committee, so to speak, the contributors provide for you. And then you can also download a lot of good stuff from the OSC website here, and also from the UberCloud website, where you can subscribe to our monthly newsletter, and certainly download all the websites which are collected in different compendiums of use cases. And with that, we thank you very much. And this is Bob, Alan, and Wolfgang.